Good morning, everyone. I hope everybody is safe and sound. Today, we will be discussing the elemental analysis of organic compounds by Tony Massad, grade 2S. Sit back, relax, and enjoy the ride as I simply run the slides, one slide after the other, with you guys. Let's start with the definition of an organic compound. Organic compounds are compounds containing the element carbon. So anytime you have a compound that is in its structure carbon element, it is classified as an organic compound. But of course we have some exceptions. Carbonate compounds, bicarbonate or hydrogen carbonate compounds, carbon dioxide CO2, carbon monoxide CO, all of these compounds contain the element carbon, yet they are classified as inorganic. So if you have like magnesium carbonate, its formula is MgCO3. It contains the element carbon, but since it's a carbonate, it is not an organic compound. Carbon dioxide contains carbon. Carbon monoxide contains carbon, yet these compounds are not classified as organic compounds. If you look at C6H12O6, which is known as glucose, why do we consider that an organic compound? Simply because it contains carbon. If you look at benzene, its formula is C6H6. Benzene is classified as organic since it contains the element carbon. Now, elemental analysis. It is the study of the structure and properties of organic compounds. In order to identify what elements are in the composition of the organic compound and how many of these elements are in the compound, and if we need to just discover the properties of the organic compounds, we have to do some analysis. The elemental analysis is divided up into two different analyses. We start with the qualitative analysis. Qualitative has the word quality in it. It allows the identification of the elements present in the organic compound. So when you run a qualitative analysis on an organic compound, you will conclude from this analysis that in this compound we have the elements carbon, hydrogen, oxygen, maybe nitrogen, maybe sulfur, and so on. So the qualitative analysis only gives you information about the type or the kind of atoms that you have in the organic compound. Now when it comes to the number of those atoms in the compound, you are simply doing what we call quantitative analysis. So the quantitative analysis allows to determine the number of the elements present in the organic compound. Let's recap. If you run an analysis and from the analysis you simply deduced that a certain organic compound contains the elements carbon, hydrogen, and oxygen. Now since you did not mention how many carbons or how many H's or how many oxygens we have in this compound, this analysis is simply called qualitative analysis. But when you simply write down C6H12O6 or you write down C12H22O11 or you simply write down C6H6, let's just say, in this case, because you specified the number of the element in the compound, this analysis is called quantitative analysis. Let's start with the qualitative analysis. Number 1, pyrolysis of sugar. Sugar has the molecular formula of C12H22O11. When you simply burn the sugar, it pyrolyzes or decomposes to produce 12 carbons and 11 H2O molecules. During this process, the white sugar turns brown, then black, as shown, indicating the presence of the element carbon. Water droplets indicate the presence of the elements hydrogen and oxygen. From this process, the analysis shows the presence of the elements carbon, hydrogen, and oxygen in sugar. So let's recap. You put a small amount of white sugar on a spoon and you expose it to open flame. You will notice that after a short period of time, the white sugar will start to turn into brown and you will see a liquid forming, and when the liquid totally evaporates, you end up with a carbon deposit. From this analysis, we can conclude that since we have a black deposit, which is carbon, this means that in the sugar we have the element carbon. And during the pyrolysis or the decomposition of sugar, if you place it in a beaker or on a spoon, you will notice that droplets of water are formed. Now, since water is made up of hydrogen and oxygen, we conclude that sugar has carbon, hydrogen, and oxygen elements in its structure. Number 2, incomplete combustion of turpentine. During this process, black soot or smoke is detected on the covering lid, indicating the presence of the element carbon in turpentine. This shows that turpentine is an organic compound. Now let's start by talking just a bit about incomplete combustion. Incomplete combustion occurs when the supply of air or oxygen is poor or limited. Water is still produced, but carbon monoxide and carbon are produced instead of carbon dioxide. Now, let us point the difference between complete and incomplete combustion. During the process of complete combustion, we have a great amount of oxygen present or available, not poor. In this case, the products are carbon dioxide, gas, and water vapor. But when the combustion is incomplete, which means that the amount of oxygen is limited, it's not available in great amounts. In this case, the products are carbon and water and carbon monoxide. Now, since we have carbon produced and water produced as well in the incomplete combustion, we have the black soot, which is shown in the figure. Now, below we have a watch glass containing some amount of the turpentine. We use an open flame to simply ignite the turpentine, which is a liquid organic compound. Now, by placing a lid above the watch glass, the black soot comes from the incomplete combustion of the turpentine, and it sticks to the walls of the lid. And if you touch the walls of the lid, you will have a black deposit on your finger, indicating the presence of the element carbon in turpentine. This means that turpentine is an organic compound since it contains the element carbon. Number 3, the complete combustion of ethyl alcohol. Ethyl alcohol is C2H5OH. It reacts with 3 molecules of O2 to produce 2 carbon dioxide molecules and 3 molecules of water vapor. Now remember, in the process of complete combustion, the products are carbon dioxide gas and water vapor. The carbon dioxide gas is made up of carbon and oxygen, and the water vapor is made up of hydrogen and oxygen. Now, what can we do to test for the presence of the carbon dioxide and water vapor? The test for carbon dioxide gas is the use of clear lime water, which turns turbid or foggy or kind of white in the presence of carbon dioxide. In other words, if you have a gas other than carbon dioxide infiltrated into a test tube containing clear lime water, it will not change color. Only carbon dioxide can make clear lime water turbid, according to the following equation. CO2 gas reacting with calcium hydroxide, CaOH taken twice, which is lime water, producing calcium carbonate, CaCO3 plus water, H2O. Now the calcium carbonate and the water are simply the turbidity or the fogginess, which simply proves the presence of carbon dioxide gas. Now the test for the water vapor. To test for the presence of water vapor, we use a white solid called copper 2 sulfate. When this white solid is exposed or is in contact with water vapor, it changes color from white to blue, indicating the presence of H2O. Now, no other compound can cause the white color to change to blue unless that compound is H2O. Now, the occurring reaction is CuSO4, which is called copper 2 sulfate, and its color is white. It reacts with 5 molecules of H2O to produce copper 2 sulfate pentahydrate, and this compound has a blue color to it, which proves the presence of the H2O. From these two tests, we will deduce that the compound contains the elements carbon, hydrogen, and oxygen, and of course, it is classified as an organic compound. Now, please, guys, you need to memorize the two occurring reactions: the CO2 gas plus the calcium hydroxide, which is the lime water, producing calcium carbonate plus H2O. And you also need to memorize the CuSO4 plus 5H2O, producing CuSO4 dot 5H2O. Now, so far, we discussed that the organic compounds are compounds containing the elements carbon, hydrogen, and oxygens. And the most important element to classify that the compound is organic is, of course, the element carbon. Now, what if the organic compounds contain elements other than carbon, hydrogen, and oxygen, elements like sulfur S, nitrogen N, and halogens such as chlorine, bromine, and iodine? Now, to test for these elements, the organic compound should be treated with hot molten sodium metal in order to mineralize it so that the element is converted to an ion to be tested. What is meant by that? If we have an organic compound and we need to carry out more tests on it to discover whether it has elements other than carbon, hydrogen, and oxygen, the first thing to do is you need to treat that organic compound or the sample of this organic compound with molten which is in the liquid state, hot molten sodium metal. What does the hot molten sodium metal do to the sample of the organic compound? It simply changes, if the organic compound contains the element sulfur, it changes the sulfur into S2 minus. If the organic compound contains, let's just say, chlorine, it changes the chlorine to Cl minus. If the organic compound contains the element nitrogen, it changes the nitrogen to Cn minus. That's why we need to treat a sample of the organic compound with molten sodium in order to change elements such as sulfur, nitrogen, chlorine, bromine, iodine into ions to be tested. Now, let's start with the test for sulfur. We have to use an ionic solution containing the ion Pb2+. I don't care what kind of solution you use, but this solution has to have the ion Pb2+. Now, if the organic compound contains the element sulfur, which changes to S2 minus when you mineralize the organic compound, then if it has S, it is converted to S2 minus. A reaction takes place between Pb2+ ions and S2 minus ions to produce a precipitate, which is a solid, called PBS lead sulfide, which happens to have a black color to it. Now, once you have this phenomenon taking place, or this reaction taking place in a test tube, you will conclude that the organic compound contains the element sulfur. If you treat an organic compound with an ionic solution containing Pb2+, and you don't get a black deposit, this means that the organic compound does not contain the element sulfur. Now let's move down to the test for nitrogen. So you take a sample of the organic compound and you treat it with hot molten sodium in order to mineralize the elements that I spoke about in this slide. But in the testing for nitrogen, we need to use two ionic solutions successively. Successive means that we need to use one solution, then we have to use the other solution right after it. What are the two successive solutions that we need to use in order to test for the presence of nitrogen in the organic compound? The first solution has got to contain the ion Fe2+. The second solution has got to contain the ion Fe3+. So here's what happens. You put a sample of the treated organic compound in a test tube. You add some amount of the solution containing Fe2+. Then you wait for a while. Then you add another amount of a solution containing Fe3+. If you witness and observe a blue solution in the test tube, this means that the organic compound contains the element nitrogen. What are the occurring reactions in this process? The first reaction takes place between Fe2+ ions and 6 Cn- polyatomic ions to produce a huge polyatomic ion known as ferrocyanide ion, which has the formula of Fe open parenthesis Cn close parenthesis 6 and a charge of 4-. Then, after the formation of this humongous polyatomic ion, we have another reaction when you add the solution containing Fe3+. The reaction is the following one. We use 4 Fe3+ in this reaction, reacting with 3 Fe Cn6 charge 4- which is the ferrocyanide ion, to produce ferric ferrocyanide blue solution, which has a huge formula. It's Fe4 open bracket Fe open parenthesis Cn close parenthesis, put 6, close the bracket, and put 3 on the outside. Now, I'm really sorry to say these two equations also need to be memorized by you guys. To recap the testing for nitrogen, because this is the most complicated one to test. First off, like I said, you need to mineralize a sample of the organic compound, then add a solution containing Fe2 plus ions. Wait for a while, then add a solution containing Fe3 plus ions. If you don't observe a blue solution in the test tube, this means that the organic compound does not contain the element nitrogen. But if you witness and observe a blue solution after the addition of Fe2 plus followed by Fe3 plus, then you have to say to yourself that the nitrogen is part of the organic compound. The two equations, like I said to you boys and girls, please, they have got to be memorized. Now last but not least, the testing for the halogens. Like I said, organic compounds could contain elements such as nitrogen, sulfur, and now we have to talk about the halogens. The halogens are the Cl, the chlorine, Br, bromine, and of course the iodine, which is I. To test for the presence of one of these three halogens in the organic compound, we need first off to mineralize a sample of this organic compound, and then we have to use an ionic solution that contains the ion Ag+, the silver ion. Any solution that contains the Ag+ can do the job. So the occurring reactions are the following ones. If the organic compound contains the element chlorine, then the reaction is simply Ag+ plus Cl- producing AgCl, which is a white precipitate which changes to grayish black when you expose it to light. Now, if the organic compound contains the element bromine, then the occurring reaction is Ag+ plus Br- producing AgBr, and this precipitate is a creamy white precipitate. What if the organic compound contains the halogen iodine or iodine? Then the occurring reaction is Ag+ plus I- producing AgI, and the silver iodide is a deep yellow precipitate. Now I think you guys noticed that these three precipitates have different colors. Silver chloride AgCl, once produced, it is a white precipitate, but when you expose it to light, it changes color from white to grayish black. Now, silver bromide AgBr, it is a creamy white precipitate which does not change color when exposed to light. And AgI, which is silver iodide, it has a deep yellow precipitate. So if you're looking at the test tube, if you, let's just say, treated a sample of the organic compound with a solution containing Ag+, you are observing the, let's just say, the formation of a creamy white precipitate. Then you have to deduce that the organic compound contains the element bromine. If you observe a white precipitate which changes color when exposed to light, then you conclude that the organic compound contains the element chlorine. Last but not least, if you simply observe the formation of a deep yellow precipitate, this is a clear indication that the organic compound contains the element iodine. And of course, sadly I have to say this to all of you guys, the equations, the occurring equations have got to be memorized. So those on that slide and the previous one, any occurring reaction represented by an equation, please, 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 I'm really sorry to say this, but you need to memorize it. Thank you so much for hearing me out. God bless and love you all, guys.